What you're listening to are pressure waves from a galaxy cluster known as Perseus, about 240 million light years away from Earth. NASA's Black Hole remix recently went viral online, and it's fueling more and more interest in black hole science, as well as its mysteries. Hi, I'm Ahmed Shahabuddin. I can imagine, like me, you have a lot of questions, so jump into today's YouTube chat and you can be part of this discussion. A black hole is believed to be the most extreme environment in the universe, an area in space where the force of gravity is so intense, not even light can escape. But how much do scientists really know about black holes and what their actual purpose is? Well, joining us today in Connecticut, Priyamvada Nadarajan, a professor of astronomy and physics at Yale University and one of the principal investigators with Harvard University's Black Hole Initiative. In the U.S. state of Rhode Island, Kimberly Arcand, a data visualizer and science communicator for NASA's Chandra X-ray Observatory. And in New York State, Jehan Kartaltepe, an astrophysicist at the Rochester Institute of Technology, where she studies the evolution and formation of galaxies. Thank you so much for being with us beyond feeling very unaccomplished after all those introductions. No, I'm joking. So many interesting burning questions here, really, but let's start with the most fundamental. Kimberly, what is a black hole?
Well, I think a black hole is a really cool thing, and it's a really interesting thing and a thing of mystery. But in essence, I like to think of them as a dense, compact object whose gravitational pull is so strong that within a certain distance of it, nothing, not even light, can escape. And many of the black holes that we sort of know and love, I guess, are thought to be the result from the collapse of a very, very, very massive star as it sort of gets towards the end of its stellar evolution.
That's a simple explanation that I can understand. I want to ask you, though, Priya, you know, when we talk about black holes, there's a lot of misconceptions. There's a lot of maybe confusion of what it exactly is. So they certainly seem to help us understand how our galaxy kind of was shaped and formed. But what fascinates you most about it?
Well, I guess as Kim just mentioned, right? So you can think of the black hole as a place of extreme gravity from which nothing can escape. And there is this region, sort of like a sacred boundary, if you will, called the event horizon. So once you cross the event horizon, nothing, no matter, not even light, can escape. So what happens inside the event horizon is something that we don't quite understand. We are starting to understand it and figure it out. But we know that the black hole actually encases a point that we call a singularity. This is where all our knowledge of physics breaks down. So for me, the fascination with black holes is that they represent the edge, sort of the limits of knowledge, right? And so trying to understand them, like you're literally pushing knowledge and our minds as much as we possibly can.
Well, I mean, that's certainly fascinating to me. I mean, my dad's a physicist. He spent much of his life trying to explain some of this stuff to me. I don't know that I got it, but that certainly it makes sense to me. I mean, so when you say singularity, that's the center of the black hole. This is where we don't have sort of the physics knowledge to really understand what's going on. Is that correct?
That's right. That's right. So our understanding, all our laws, right? Nature has all these laws, these symmetries, and everything kind of breaks down when we approach the singularity.
Interesting, fascinating. Jehan, when we talk about sort of galaxies and how they've evolved, I know a lot of your research focuses on this. We have people in our live YouTube chat right now actually asking some pretty pointed questions I want to share with you. One of them says, do black holes lead to higher dimensions? And maybe the most interesting one to me from Solid Cancer says, can you have 2 or 3 black holes that have joined together or merged?
That's a great question. So my research focuses on galaxies themselves and how they form and evolve over time. But I'm especially interested in what happens when 2 galaxies merge together. And we think that all galaxies have these supermassive black holes in their center. So when those galaxies merge and become one, those black holes should also merge and become one. And just recently, we got evidence of this process through the gravitational wave detections by LIGO, which actually observed what happens as a result of this merger and the gravitational waves that are emitted that we can detect all the way here at Earth.
And I see that visual that we're sharing with our audience. It's like I see these things and it fascinates me, but I fear that I don't understand just how fascinating it is. But we have this headline as well I want to share with you, Jehan. It says a pair of supermassive black holes could be fated to collide within 3 years. Certainly sounds like something we should be anticipating. Is this doom and gloom? What does that mean?
It's definitely not doom and gloom. From our perspective, we won't see too much different. If we're lucky enough, we'll be able to detect gravitational waves from this merger and be able to study a little bit about the last moments before the merger actually happens, which would be really useful for physics. But otherwise, not too much changes from our point of view. It's certainly not doom and gloom.
And we've seen images. We heard that sound at the top of the show, Kimberly. I know you're working to kind of figure out, in a sense, to put it in layman's terms, if we can make an image of the black hole and also with the sound. Could you share with us the sound, kind of what it is, what it means? We were joking before we went live. To me, it sounds like Stranger Things. It certainly sounds a bit ominous. But how are we experiencing the data that we're collecting?
Yeah, I'm a Stranger Things fan as well. So I think I really love that analogy about the sound. And I've heard other people talk about how it sounds to them like a horror soundtrack, or it just sounds like something from Hans Zimmer. It's this idea, the sonification is pretty cool because it actually took an archival result from 2003 from Andy Fabian et al. And in that result, they had made this discovery that this massive black hole was just belching out into the surrounding environment, and those belches are sort of causing these pressure waves or these sound waves in the hot gas. And so those sound waves we could actually translate into a tone, which was B flat, about 57 octaves below middle C. So way, way below human hearing, like hundreds and hundreds of piano keys below human hearing. And I think this idea that we could then take that today and sonify it, so take that note that we know it's singing out into the universe and turn it into sound that humans can hear, was really exciting, because to me it's a way to not only learn things about them but also help communicate them to people, for example, who can't see, someone who's blind or low vision.
Yeah, and that was part of it. I mean, that's doubly fascinating. I think we want this show to be as accessible as possible, and part of that means kind of breaking things down. We hear these terms like not even light can escape from a black hole, and we're going to dissect that further. But for now, I want to share some comments that are coming through on YouTube. We have Neptune asking, what is the nearest black hole to our solar system, and is it possible for them to collide with us in the future? Who wants to take that? Priya?
Sure. The nearest supermassive black holes, right? All three of us are interested in these sort of overweight cousins of the little black holes that the LIGO collaboration caught colliding, right, is the one at the center of our own galaxy, and it's 4 million times the mass of the sun. And I mean, I think the rest of your question was what? The nearest one, and?
Might they collide with us in the future? It's that age-old question of, yeah.
I think we are safe. We are quite safe, and I think the one at the center of our galaxy is actually sitting very quietly. It's feeding on a very tiny trickle, and it's largely dead for most purposes. But it's a fascinating one for us. That's right. You're showing the up-close image from the Event Horizon Telescope collaboration, which is as close as we will ever get to a black hole.
Interesting. Wow. Well, I mean, a lot of these questions, I have to share them with you on YouTube, are kind of better than my questions, or at least they're the exact same as my questions. So here we go. Buzz Video is saying, how can we learn about black holes if they trap light and can't actually be seen? Now, I see that you're nodding, Jehan. So I'm going to ask, I mean, we hear this phrase, not even light can escape. What does that really mean? And yeah.
Yeah, I'm nodding because that's a question I've heard a lot, actually.
Okay.
Right? We're trying to study something that we can't see. We're trying to understand the absence of light, and that's a kind of complicated concept, right? The video you showed earlier, you saw these sort of black spheres in the middle that are representing the black hole. So we can't see into those black spheres, but what we can see is what's happening around them, how those masses are affecting their surroundings. So they're still interacting with things gravitationally, so we can measure things nearby them and see how their movement is affected by the presence of something really massive. We can see how their masses distort light. We saw that in that video that you showed. And we can learn all about their surrounding environments just based on the material that's nearby, right? If there's gas that's surrounding them, then that gas moves very rapidly, it gets very hot, and we're able to detect it through X-rays and other parts of the spectrum. So we can still learn quite a lot about black holes and the effect on their environment just by observing what's near them.
Interesting.
And,
please.
I'd love to jump in.
Go ahead, Kimberly, and then we'll come. No, Kimberly, go ahead.
Jump in first.
So I love the idea that we're looking at this data now, and we're talking about data that is essentially invisible, right? All of this material that we've been talking about, the sonification and that image even from the Event Horizon Telescope, these are in different kinds of light that human eyes can't perceive. That we can't see in X-ray light, we can't see in radio light. So it's really important to consider like all of these things that are happening out there in the universe. So much of it we can't see, and we need different telescopes like the Chandrasekhar Observatory, like the Event Horizon Telescope, in order for us to be able to learn more about them. I like to think of like the Chandrasekhar Observatory as like a black hole hunter. It's found black holes near, far, small, big, even medium-sized ones, kind of like a Goldilocks thing, I guess. There's so much to learn for these little special laboratories that are out there in the universe just waiting to be studied.
And Priya, you were going to say something. You were going to ask.
Yeah, I'm going to say, I'm also often asked this question, what does it mean that even light can't escape, right?
Yeah.
So one analogy that we've all seen, right, from Cape Canaveral, you have to boost rockets out so that they escape the gravitational grip of the Earth. So we have to give rocket fuel, boost it up to 11 kilometers per second, and launch them to free itself of the Earth's gravity, so it doesn't fall back, right? It sort of escapes. So if you just imagine that's telling you something about the gravity of the Earth. So that's what it's doable. The gravity, intense gravity of a black hole is such that escape speed, that rocket speed that you need to give, has to be the speed of light. So that's what we mean when even light cannot escape a black hole.
Interesting.
Yeah, and how do we, coming back also to this question, as Kimberly and Jehan pointed out, we map these invisible entities indirectly. In the case of a black hole, so it is feeding on gas. So gas is being pulled in, again, by the gravity of the black hole. As the dying gasps of the gas, as it's getting pulled in, it gets heated and it starts to glow. And that's what we are seeing in the X-rays. So we don't actually see the hole. We see the stuff that is en route to.
I do want to ask you about these images. How did the Event Horizon Telescope create the image, this image of the black hole that's at the center of our galaxy? Take a look. We have these are two different images, right? Comparing. Help me understand what this is for our audience. Comparing the size of two black holes, the M87 and Sagittarius A. What is significant about this that can be understood by someone, a simpleton like me? Priya?
So what we are seeing is we have zoomed in to a region that is right around the event horizon of the black hole. Remember that sacred boundary that where not even light can escape. We're a little bit outside it here, but we've zoomed right in there to the heart of a black hole, if you will.
Okay.
And these are two black holes. The one that is the center of our galaxy, Sagittarius A star, is 4 million times the mass of the sun. The one in M87 is 6 billion times the mass of the sun, much more massive. Okay. And the way the Event Horizon Telescope project managed to zoom right in is they leveraged many radio dishes that are scattered around the Earth to mimic and make the entire size of the Earth behave like one radio dish. And so that's the biggest telescope we can make.
It's great. Crazy to me. I mean, when we talk in these numbers, these figures, it's hard to wrap my mind around it, but that's just me. But Kimberly, that's why you're here. I've read that you kind of talk also about, and by the way, it should be mentioned, the Event Horizon Telescope, for those who don't know, because this is really cool, you can rat out and geek out on this. There were 11 telescopes synchronized around the world, right? creating sort of a virtual Earth-sized telescope, as we just heard Priya explain, to take these images from far away. So there's so much we know, so much we're learning with the data, so much we don't know, though, Kimberly. Like, what is ultimate, like, are there cosmic recycling centers? Did I understand this right? What might that even mean? I mean, are they recycling up there and we're not recycling?
Yeah, well, I'm a huge fan of recycling, so I think I really like black holes and things like supernova remnants because they are the ultimate cosmic recycling centers, recycling at a much grander scale than humans can ever hope to do. I do think black holes sort of have a bad rap. They've got this sort of negative reputation for being just cosmic vacuum cleaners, you know, things of doom and gloom. And yes, nobody really wants to get too close. I don't want to be spaghettified if I, you know, fall into that gravitational pull. No, thank you.
Right.
I am happy here on Earth and all of that. But we have a lot to be grateful for, I think, as well, to black holes. You know, the stellar explosions that produce many of the black holes that we know about, they're also spewing out other really important elements. When black holes collide, those types of collisions are giving us even more elements. And those types of elements we use here on Earth, right? So there's a lot about this idea of cosmic recycling that I think is very attractive, that it's not just doom and gloom, that it's also creation and potential future life.
Right, and you know, we see or hear or think of black holes as sort of something, as you said, destructive. I'm glad you brought up this point because it's really kind of, you know, in the popular culture, if you will, that's how it's often referred to. But your research really frames it as a creator, as an engine, if you will, in the galaxy. So in a sense, it's nice that today and through your work, in a sense, we can flip the script, if you will. And with that in mind, I want to share this with you three. Priya, maybe you can share your comments on this. We got a video comment that was sent to us from a professor of astrophysics, Jarrett Lewis. Just take a listen.
Black holes are mysterious places, surrounded by a one-way barrier known as the event horizon. You can fall in, but you can never get out. What happens inside the event horizon, we don't really know. Some think that you might just fall to the center and be crushed at the singularity. Others have suggested that black holes might be portals to other universes. You might fall into a black hole in our universe and pop out of a white hole in some other universe. But it's going to be a brave person who jumps in to try and find out.
I mean, I am willing to be that brave person, but only because I don't know what you know waits ahead.
Not me.
No, I'm joking. But what do you make of that, Priya? I mean, the way he frames it, maybe it's a bit in jest, but what do you think?
No, it's great. First of all, hi, Geraint. I actually know him. We were
small world
in Cambridge. It's a small world.
Yeah.
No, but I think he's absolutely right that we don't really quite understand the fate of matter and information. When I'm going to sort of mix them up now and say anything that falls into the black hole, information about it, right? In fact, Stephen Hawking had a very nice analogy. He said, no, suppose you look up the Encyclopedia Britannica, right? And I look up Al Jazeera and I can see it's this great network that reaches all these people. There's information, right, in the encyclopedia. Now I put the encyclopedia in a closed box. I lock the box completely tight, and I burned down the encyclopedia. All the information that was in the encyclopedia is still in the box. It's just that we don't know how it's stored anymore, and we don't know how to retrieve it. So that's sort of where we are with understanding what happens inside a black hole. There is much to understand. So one speculation is that it's a portal to a new universe.
I really appreciate you breaking it down in very elementary terms. That analogy helped me certainly understand it. And for those who are listening to the video comment from that astrophysics professor, he did mention the event horizon. Just to clarify, I want to make sure that I'm actually learning things. That is not only the point of no return, which is a region, basically a space around the black hole where light and matter sort of get sucked in. Okay, so we're learning here together. Fantastic. We also have a comment about sort of vibration. We hear this term very often when discussing sort of the world and the physical world. Buzz Video is asking, light can't escape black holes, okay, but can vibrations escape black holes? I'm not sure I really understand the question, but hey, he asked it a few times, so. So silence in the studio. I love that. Priya, vibrations. What is there anything that can escape a black hole?
Right, no, I don't think even vibrations can escape a black hole, right? So the vibrations that we are detecting in the sonification, right, are the impact, the result of black holes' gravity interacting with that gas that's trying to fall in. So not all the gas that gets swallowed makes its way in. There is some that is expelled out. And I think, as Jehan mentioned, there's a little bit of belching that's happening, right? So there's material that's also coming out. So the sound needs a medium, right? So because you have this gas, these pressure waves, we are able to hear them. And so that's what they're not really escaping from inside the black hole, but they are generated by physics that's happening at the edges of the black hole. So that's an easy way to put it. If you want a nerdier version, I can.
No. Save the nerdier version for later, after the show. That was great. You're doing great. I want to ask about the misconceptions a little bit before we wrap here. You know, wormholes and all these sorts of other things that we hear about. I mean, what are sort of some of the challenges? What are the limitations? With all this exciting research, like what are we still struggling really to understand, or what excites you looking to the future in terms of continuing to do this work? Anything on your mind, Jehan?
Oh, one of the things I find most exciting about the future of this field is just understanding how this all began. You know, when did the first black holes form? How did they form? There's a lot of mystery surrounding that. We are detecting galaxies with really massive black holes at periods of the universe that were much earlier than we thought they should exist. And they're already big, they're already massive. We call them quasars. They emit a ton of light. And so we really don't understand how black holes could have formed so early on in the universe's history and gotten as massive as they did so quickly. And so that's one of those big open questions. It has a lot of people scratching their heads and theorizing, and hopefully we'll know more about that in the future.
Well, and I saw Priya and Kimberly not scratching their heads, but nodding their heads as you were bringing up those points. So that's all well and good, that it's something you mutually agree upon. I do want to share with you one more comment we have from Ujwal Das. This might be an obvious one, but how is time affected in the black hole? What's sort of the easiest way of kind of understanding that? Kim?
I will pass that one to Priya.
Priya, time. How about this? Well, no, I don't want to sound... No, let's just go with time. I mean, what is time is what I was going to ask, which is way too existential. So I don't know if that's that's correct?
Yeah, but I think what really happens, right? So this is the other reason black holes are so bizarre. Time really slows down once you cross the event horizon.
Okay.
So, and what really happens, right? So we have the universe, we think, is a 4-dimensional sheet. So you need to specify where something happens. You need to say it happened in this space. So three numbers to tell you where, and one that tells you when. That's the time, right? So you have space and you have time. So this together form these sort of sheet called space-time. When you cross a black hole at the event horizon, the strangest thing happens. The nature of space and time flip.
Flips. Okay, so I'm just...
with that, hold that.
Flips meaning what? Flips like inverses, like does a backflip?
I mean, time starts to behave like space.
Okay.
So in a sense, the flow of time gets affected. So as I said, time really, our notion of time, it gets really slowed down. It really slows down. And as you reach the singularity, it sort of starts taking infinitely long, longer and longer to reach that.
It's fascinating to hear you explain that. It sounds to me like you're describing a Monday morning where time just seems to slow down. But hey, that's my ability to make sense of this. I want to thank you all. This has been really enlightening and engaging. So thank you for joining us, Kimberly, Priya, and Jehan. For those of you at home, thank you for sending us your questions. Hopefully we got to a lot of those YouTube questions. And remember, here at the stream, these conversations do not end on air here on television. You can always follow us at AJ Stream, both on Twitter and Instagram. Stay tuned.